Okay, lesson 6.2 is all about getting us ready for looking at projections that aren't projected horizontally or vertically. They're projected at some angle in between. And the first example, example 4, talks about a particle being projected from a horizontal plane with initial velocity of 40 meters a second. But the key part here is that it's not being projected. It's not being projected at an angle parallel to the horizontal distance. It's being projected at an angle of alpha, and it tells us that information, that tan alpha equals 3/4. Okay, so what you might remember is that I've done previous questions on this where we say that any time they give you something like tan alpha equals 3/4 in the question, before you even proceed, you should go away and you should work out the values of sine alpha and cos alpha. Now the way to do that is not to work out alpha itself. That can lead to rounding errors. It can lead to rounding errors, and it can also be quite messy really, because you might have long decimal answers because they might not be nice angles. But this one's very simple, because actually if we draw the little triangle with alpha, tan is opposite over adjacent, so opposite is 3, adjacent is 4, and then you can square and add them together and you get 5 there on the hypotenuse using Pythagoras. So then we can just read off that sine alpha is equal to opposite over hypotenuse, 3/5, and that leaves cos alpha as adjacent over hypotenuse equal to 4/5. So there's my sine alpha, cos alpha. Why do we want those, you might ask? Well, it asks us to find the horizontal and vertical components of the initial velocity. Well, just like we were doing in Unit 5, we can use a very similar technique here. So if we want to find the horizontal component of the velocity, we can see that the horizontal is here, right? This little horizontal line. And this 40 meters per second is an angle of alpha away. So if I wanted to go from 40 meters per second to this line, I would move through alpha. So just like before, when we said that if we move through an angle, that must be cos of the angle. It works exactly the same here, even though we're dealing with velocity. So this is 40 cos alpha, which is going to give us 40 times 4/5, which is 32, and obviously it's a velocity, so it's 32 meters per second. So the initial velocity would be 32 meters per second to the right. We can do the same for the vertical, right? And if we draw in this vertical line, we can see that to get to that vertical line, we have to move away from the alpha, so it's going to be 40 sine alpha, just like our previous work on this. So this is 40 times 3/5, which is 24 meters per second. Okay, that's part A. Part A just asks us to find the horizontal and vertical components. Part B then says that given I and j are unit vectors, the unit vectors you're used to dealing with, express the initial velocity as a vector. Okay, well this is going to work exactly the same, right? We've got to the right in the I direction it's 32, so it's 32I plus 24 in the vertical, 24j meters per second, right? If they want it as a vector.